Hey, welcome back. So let's have a look at several different classes of chemical reactions. There's lots of different classes here. We'll just focus on two main ones. We'll focus on what we call precipitation reactions, and then we'll focus in on acid-base reactions. So you want to make sure that you can identify the difference between these two and you can classify these. And what do I mean by a precipitation reaction? Well, precipitate is something that you may have heard about in lab already. We normally abbreviate it as PPT, and it is an insoluble solid. So imagine you do a chemical reaction in water, so an aqueous reaction, and you form something that doesn't dissolve in water. That would be an insoluble solid, which we would call a precipitate. For example, right, we could imagine mixing, and maybe mix this in lab actually, if we mixed lead to nitrate, okay, which is soluble in water, so we were AQ, with something like potassium iodide, so Ki, and I've actually already kind of cheating here, I already know how to balance it. It forms, what does it form? It forms potassium nitrate, and it forms two of them, so that's 2KNO3 aqueous, and then it forms something that is an insoluble solid, and so it forms lead to iodide, PbI2, and I'm going to write an S next to it. And it is pretty common to write a Dan arrow next to it because when you mix these together, it forms that insoluble solid, and that solid in, say, a test tube will sink to the bottom of the test tube. And I've got a short little video here just to show you in the top right-hand corner, okay? So wasn't that beautiful? So the lead nitrate and the potassium iodide. So the solution had potassium iodide in it, and we were dropping in little bits of lead 2 nitrate, and when they mix together, they form that insoluble lead 2 iodide, that yellow color there. Sometimes we call this the gold reaction. Not that we're making gold, but it's a golden color. It's absolutely gorgeous. So that's precipitation reactions. And we'll have a quick look at acid-base reactions here as well. So if you remember, acids are things that form the H plus ion in solution, something like hydrochloric acid, HCl would be a classic example. And bases are things that contain the hydroxide ion, so something like lithium hydroxide would be great. So you really have to kind of identify the acid from the fact it contains the H plus ion here, and it contains the OH minus ion here. This is called the Arrhenius theory of acids and bases. We'll spend a whole chapter kind of looking at this stuff. And what do they form when they react? Well, it turns out when they react, they form what we call a salt plus water, so they form lithium chloride. Okay, so salts are just ionic compounds. So we often just refer to an ionic compound as a salt. So I should go ahead and write that on the left was an acid, and that was a base. And then the other combination, actually, when H plus and OH minus come together, they form a water molecule. So we say acids and bases normally react to form salt plus water. So that's a classic reaction. It also gets incredibly hot. So when you run these reactions in the lab, they give off a whole bunch of heat and feel very warm in the process.